Hello, this is Benedict, representing Team Alyssa. I will be talking about how our team uses neural networks to facilitate deep learning so that we can predict and forecast wind energy production in the region of Île-de-France, France. Our objective is to forecast 18 hours ahead. And these are the steps that we are taking to extract and clean data, normalize and establish persistence. We configure and establish our neural network, and then we feed and train the data to beat baseline risk. We have two sets of wind forecasts from 8 major wind farms. We also have wind energy actuals from the French Energy Transmission Authority, RTE. Data is in non-standard units, so what we had to do was to extract them and then interpolate them into hourly data. Note that there are two data sets, dataset A for energy forecast, dataset B for wind direction and speed. We use the following equations to normalize both of them. As for persistence, we pick the persistence from dataset A. In configuring and establishing the neural network, we've decided to implement basic feature engineering of a moving window of 4 hours. What about our parameters? We've opted for a neural network size of 256 with 4 layers. Our solver is SGD, which gives us better results instead of Adams, and we set a regularization of L2. So we ran our model, and the result of our test loss is that we managed to achieve a test loss of 3.16 to the power of minus 9, which beats the persistence of 4.59 to the power of minus 9. Yeah. However, our lagged correlation peaked at 18, and this is suboptimal. To improve this, we made multiple attempts to increase inputs so that we can reduce the figure of 18 to somewhere closer to 0. However, the system returns errors whenever input is changed, thus we are not able to rectify these less than optimal results. Our visual prediction graph displays a lag against the actual, which suggests poor prediction ability. Perhaps you can take comfort in that our scatter plot is reasonably tight. In looking at our actuals versus test predictions, the prediction shows more extreme outliers, and clustering seems concentrated around the regression line, which is acceptable. At the time of recording, we have a net profit of approximately 50,000 euro. However, this may not equate to good prediction ability because you could see that our lag correlation peaked at 18. This was mentioned earlier. As a final point of discussion, there are things that we can do to improve our model, such as to do more feature engineering. We may also want to do more model configurations, such as altering the number of layers, and we can also test the regularization to identify an optimal model. We have already done and tested several configurations in our attempts to date. However, more is always better. Lastly, we can perhaps change the training and test data ratio and alter the neural network input size to improve the prediction lag. To close off, I would like to thank the gentleman at AI for Impact for mentoring us and bringing us so far. Thank you very much. Signing out, Team Alyssa.